architecture of DGBX, and it sounds more like it's both platform as a service and data as a service. Have you looked at the percentage of use cases? How many people are actually going to do image classification versus those that, hey, I just want the answer. I just want the building footprints, for example.
Got it. Yeah, so the answer to the question is yes, and it wasn't me, and I know a little bit about that, but that is clearly the research that's being done when we think about how to optimize not just how the platform works from an architecture perspective, but how we present it to people, right? If everyone is going to want to just get a building footprint, or 10 building footprints, then we need to talk about it differently, right? One of the entry points to this is you got to build your own analysis for a lot of things, like for you got to make a Docker if you want to do something custom, and not everybody knows how to do that. One of the things that we are doing, though, to address that, which I think is maybe a self-propagating way of addressing that, is we've built the architecture so that anybody can load their algorithm on it, but if they want, anybody else can use that algorithm, right? So if I wrote the best car detection algorithm ever, and I put it on the platform, and everybody who gets on the platform, they get on to use that algorithm, I get paid for that, right? And so all of the customers that Digital Globe has are looking at using the platform for analysis, and so that whole customer base is available to anybody who develops an algorithm. And so, to your point, if that's what people want to do with it, then those algorithms will propagate up and be the ones that get used, and we'll be paying attention to that and optimizing to make sure that they run easy and fast and that sort of thing.
On the side, I don't exactly which.
How about green? Does that work?
You're good.
Right. I think your approach is spot on. In fact, you may have heard me rant about doing the same thing with LiDAR a little bit earlier. Opportunities here are, where can we put standards into this pipeline so I can build an analytic once and drop it in anywhere? Thoughts?
I don't think agreed is a good enough answer. Yeah, so we're really struggling with this, right? I can't just give data away. And so, that's out. And we got to provide access to very big, heavy data. And so how do you do it so that it's standardized? And there's all these different platforms and algorithms and things like that. I don't know how to solve the problem. I feel like this, being in this community and talking to this community that's why we're here.
Well, you've actually got two problems to solve. One is, how do we structure the interfaces and interchanges in your processing pipelines so I can plug and play. Second question is, how do I meter that so that I can recoup the cost of providing the service to the end user?
Yeah.
That's two different questions.
Yeah, the metering one is a hot topic.
The metering one is a hot topic, but look at the way Amazon does it. Amazon meters everything. And that's probably what you'd be looking at from a business case point of view.
So right now, there's two parts to there's probably a bunch, and we can maybe talk about it at some point, but there's the part of, I want to write an algorithm and it needs to be able to use the data that's on the platform, right? And right now we're using all of the standard drivers that software uses, right? So you can use any of the open source tools you can get to run on a Unix box, you can run on the platform. So that's one way in which we're leveraging the standards that are out there. And the other is standardizing the REST interface. And if we're going to start talking about standardizing REST interfaces, I think we're going to have a very interesting conversation because I don't know, that seems like the Wild West to me at this point. So.
Well, wait for the REST reports to come out of OWS 12. I think that'd be very good. But, yeah, I would like to figure out where we need to plug in new standards into this pipeline.
Yeah, we would also like to talk more about that.
Yeah, just to follow on that comment, it seemed to me that you've got a customer base that really pushes standards for transaction. The end game is to get the information to the customer. However, where the processing is, the end game can be through standards. You have the ability to use those very standards in the back office in your process to get efficiencies and agility. And I would think that Digital Globe, as a major user of AWS or any other cloud service, would be able to influence in the same fashion promotion of standards to increase agility in the cloud as well. Do you see that as a standard function of your interaction with the cloud community?
So I'll say a couple of things in response to that without actually answering your question properly.
Oh, great. Appreciate that.
I know you look forward to that. So the first one is we actually do work a lot with OGC to try to figure out how to develop standards and to take what we're using that a lot of people are using and standardize it and that sort of thing. And I think we're pretty proud of that participation. It's one of the reasons that we're here talking about this part. Influencing Amazon, I just don't know, right? We're a big user of Amazon. We have a lot of data up there. We influence them in some ways. It's like the GPU stuff. We put pressure on them to get the drivers in. But we're, when you look at what other people are doing with big data, like 70 petabytes sounds like a lot until you start looking at some of these other, data stores. We're not that big to be able to influence them in that way. So I think what we want to do is we want to at least have the visibility of using the standards, right? So we use them where they make sense internally. Like this, I'm drinking the Kool-Aid. Like that analysis that I showed you is something I'm actually doing on our platform. But the application of standards is, it happens where it makes sense. It happens where it gets us efficiencies.
Hey. Okay, we're going to have Rob and then Peter. You can, time for 2 more. Peter, you can talk with
We need to be wrapping up soon.
Cool.
Okay.
So yeah, question being, so I understand how you could sort of, oh my god, the feedback. That was good with the speaker. Supply a algorithm via, you make a Docker image and then it runs in a Docker container. And if I had like a Spark process, I might have.
We're hiding another microphone in your
I
jacket.
guess so.
It's wired.
Yeah, so if I had a Spark process and I wanted to pull down tiles, I could actually pull tiles in parallel from like a REST endpoint and then use those tiles like in a distributed process. Is there any way with the GPDX that I can actually run a distributed processing algorithm that doesn't just use one machine? Or are you restricted to writing something only for one machine and then just like scaling sort of vertically with the instance type?
Yeah, so right now we're handling the distribution of processing behind the firewall, behind like inside our framework. We're not yet at a point where you could say, I would like to spin up 6 boxes all controlled by my Spark process that are doing these things. It doesn't really work that way. But that is kind of the next generation of what we're thinking about, right? We've sort of started with how do we actually make it work and how do we actually get value out of it? And then we're looking for those sweet spots where we can expand it. And for our own processes, so if we run atmospheric compensation, is actually kind of a computationally intensive process, and we've sort of optimized that. So when that one runs, it runs on the right number of machines and parallelized just right. But there's definitely a paradigm, this paradigm where we're allowing people to write their own code. It's hard to give all the flexibility. Like we have to constrain it in some ways. It's a great question, and the answer is no, you can't do it. Yes, we're looking into it.
Do you have a question?
We need to wrap up.
Peter will ask his questions.
That would go into your time anyway. So.
No, I won't.
Okay. Our next speaker is Peter Baumann. He's going to talk about big data cube analysis.
I think we ought to thank our last
I can do it. I follow the previous example and take the big one. Okay, so great to be here, and I really enjoyed the previous talk. That was fun and exciting because it very much matches with things that we do, although not yet on 70 petabytes, so I do find that impressive. So to me that is big. Actually, I must confess, I'm a database guy as well, just as Keith is. And so actually, looking at that device, I try to find out how to forward. And the winner is not me. How do I forward here?
Arrow keys and clickers.
Maybe that means you need to do it wrong.
No? Yes. Cool. Actually, stepping back a little bit. So, database guys like to think in terms of structures, recognize structures, and then see operations on them. Let's focus on the structures. This is a very random collection of things that keep us busy these days, and that we tend to subsume under big data.
And if I step back and do an abstraction, then you find actually that we have a few data structures that occur over and over. So just to pick randomly, in satellite imagery, well, we have two-dimensional, three-dimensional arrays. In biotaxonomies, we find hierarchies. And social networks obviously form large graphs. Okay, so we have a few core data structures, and that means we can focus them out and end up with a very small set of things to be supported. So that's my abstraction idealization of the world. What if we could support these data structures? Could we maybe serve a lot of different applications simultaneously with the same and with compatible cross-domain technology, some horizontal technology? That's something that SQL actually has tried since now, and they have been remarkably successful in the field of sets. So that is what relational databases can do really well. We are working on others like XML databases, try to conquer hierarchies, and graph databases is an exciting area of research. Our field is looking into arrays. We have been talking about that in terms of images and other stuff today. So if we talk about that from an abstract perspective, what can we do? And that is where I want to deepen one aspect that Keith has mentioned earlier, and that is array databases. So we said SQL has been tremendously successful. Okay, but in business world, not here. We use it for metadata, but not for the real big thing, for our pixel data. Because, unfortunately, SQL does not support arrays. Good, we said. If that is the issue, then why not put it together and inject support for massive multidimensional arrays into SQL? And that is, in the end, what Rasterman does. This funny name stands for Raster Data Manager, and that is the technology that we are developing now over 20 years meantime. And you see the raster data here. That was at a time when you couldn't call it array data. Nobody wanted to hear it then. Behind the interface of this declarative query language, we have a scalable parallel architecture that we call tile streaming, and I'll talk about that a little bit. And that actually has seen quite some investment over a series of research projects and commercial projects. It is in operational use. I will show you examples then. And it is a blueprint for what you could call Datacube standards. And actually, arrays, the bare arrays, of course, they don't know about real world, about curvilinear grids, for example. That is something where actually the OGC standards come in, and that allow us to deal with any kind of such warped and curved grids as well. That has been recognized by a few people, and we are very proud and happy that we have been recognized by the Copernicus Masters Challenge as the Big Data Challenge winner, Geospatial World Forum Innovation Award, and the US magazine CIO Review picked us into the 100 most promising big data technologies. Great. So, what's behind? I said SQL. Just giving you an example, because that is something I like to see images. Database people are not used so much to images, so I always like to play with that. And the computer graphics people educated me, hey, did you know, if you take a PNG image and you put elevation data into the transparency channel, then actually this can be rendered by WebGL into a three-dimensional landscape that you can turn and tweak in your browser. Cool, we said. That is something we can generate. And so we wrote a query that has the well-known select from strategy that you know from SQL. And we are obviously looking into satellite images and DEMs. Let us assume that we have just one for now. And in the red, green, blue channel, we put in bands 7, 5, and 0, whatever, of some cutout. And in the alpha channel, we put the elevation model. Now they come with different resolutions, so we need to apply a scale operation on the DEM, and then we can fit it into a PNG, and that's what we ship to the client. And the client then can render something like what you see here, that's a screenshot in the background, generated from such a query result. So, what you can do with such queries is, you can extract data, yes, but actually you can even shift that, push that into visualization. You get a visual inspection of the data contents. So, that is just for giving you a very, very brief course overview of what such a query language could look like that has array operations injected into SQL. For those who want to dive deeper, yes, you can go up to linear algebra operations. Here's an example for a matrix multiplication and histogram computation, but that is really something for an offline talk if you want to drill deeper into this one. Rather, I hasten to say that, of course, this is not a user interface. Database people thought that initially, structured English query language. We don't think so any longer, since some time, since some decades. But actually, SQL keeps on being an excellent client-server programming interface. And when we build our web applications, then you use your PHP or Python or Perl or whatever, and have queries to contact your database. Okay, so actually what we want to do is, we want to leave people in their ecosystem. So they are familiar with some particular environment, and they should be able to work on the big data cubes in the background without leaving their comfort zone. So for the programmers, Java, C++ interfaces. Python is something that we have, and R is something we are working on. And then there's, of course, the many, many geotools out there, like Quantum, GIS, Leaflet, NASA Whirlwind, that can connect, and this is where the standards come in, via the OGC interfaces. Because going via something like Web Map Service or Web Coverage Service,